Hello everyone again. In this video we are um, going to have one step further about our perceptron, and we're going to talk about the limitation of this perceptron and what it can do and how we solve it. So in our previous video we said that a one layer, one um, neuron perceptron is only a linear classifier. But for the cases where our dataset, let's say, is like this, we have red data points here. This is one class, and the data points of other class is here. As you can see, it is impossible to separate this with a line. And instead of using one perceptron, we will use a multi-layer perceptron. And this problem is actually called XOR problem, and I will tell you why. So let's say this is 0, this is 1, and this is 1, and yeah. So as you can see, we have two features, x1 and x2. And for blue, we have 0, 1, 0, 1, and we get blue. We will just denote it as 1. For 1, 1, we get 0. And for 0, 1, for 1, 0, for 1, 0, what do we get? 1, 0, 1, and 0, we again get 0. No. So x1 is 1, and 0, 1, 0, we get 1. Oh, actually, we have to denote the blue class with 0. 0. And in this case, 1, 0 is again 0, and 1, 1 is 1. Yeah, 1, 1, 1, because these are 1 classes, and these are 0 classes. So 1, 1, 1, 0, 1, 0, 1, 0, 1, 0, 0, and what do we have? We have left with 0, 0. Yes, 0, 0 is this one, and it should be 1. So this is basically XOR problem. And there is no way that we can use a linear classifier to have a classification model like this, because we will need something like this. And in order to have this, what we can do, we can actually stack multiple perceptrons. Let's say we have one perceptron here. We have one perceptron here. And then we have another one here. And then we have x1 and x2. And let's denote the parameters. Let's say this is 1, 1. This one is also 1. And this one is also 1. And let's talk about our step function. Again, step function here, if z is greater or equal than 0, then we give it 1, otherwise 0. So we are going to try to have a model that correctly classifies these x1 and x2, and let's say our b parameter for this neuron is minus 3 divided by 2, and for this one we have minus 1 over 2. And then we have other perceptron that has a parameter of minus 1 over 2. And let's give it a try. Let's try 0, 1. So here z becomes, so now right now it's 0, 1. 0 multiplied by 1, 0 multiplied by 1 plus 1 multiplied by 1 minus 3 divided by 2, and what do we get here? We have 1. We can write it this, and then we get minus 1 over 2, which is smaller than 0. So we actually do it inside here. We calculate the weighted sum, and then we apply the step function. And the step function will give us, I also forgot to write the weights here. And our step function will give us 0, because z is less than 0. And here, what do we have? Let's calculate the z here. Z is equal to 0 multiplied by 1, the same, plus 1 multiplied by 1, minus 1 over 2, which is 1 over 2, and this one will output 1, because this is greater than 0. And then here, we calculate it here again. What is z? Z is equal to 0 multiplied by minus 1 plus 1 multiplied by 1 minus 1 over 2. And what we get here is 1 minus 1 over 2, which is 1 over 2, that is greater than 0, and then we get an output of 1, right? 0, 1. Now why did we get 1? We actually made a mistake here. 0, 1 should have been 0. Let me just check it. So the first 0, 1, the lower left neuron computes minus 1 over 2, which is negative, so it outputs 0. Okay, this one is correct. What about this one? The lower right neuron computes 0 multiplied over 1 plus 1 plus, yeah, so it outputs 1. So it should also output 1. And it should... So it outputs 0, this outputs 1. Okay, that's correct. This is correct. The output neuron receives the outputs of the first two neurons as its input. So it computes 0 minus 1 plus 1, 1. Okay, 1 over 2, which is greater than 0. Yeah, this is correct. It should output 1. 0, 1. So 0, 1 should be actually 1. My mistake was here. 0, 1, 1. Wait. I don't think that I've correctly written XOR. So 0, 1, 1 should be 1. 1, 0, 1. Yeah, I didn't write it correctly. 1, 0, 1. 0, 0, 0. And 1, 1, 0. Yeah, actually, I remember the first time I actually changed these, I should have kept it at 0, the label. Sorry, I could have it as 1, not 0. So as you can see, this layer of perceptron is able to, if we just run all of these with these parameters, it will correctly output our classification. And I just want to show the picture. Yes, I will not show. Yeah, change my mind. Yeah, this is basically the idea about multi-layer perceptron. And this is the way that we can actually, this is basically saying that by stacking up more neurons, we are able to capture more complex relationships. And of course, the training in this case is we cannot use the same training as here in our previous perceptron because the architecture is entirely different, and we're going to talk about in our next video about how do we actually train this kind of multi-layered neurons. This is the very, very basic deep neural network. You can also say that because there's a hidden layer here, which is, this one is a hidden layer.